In this episode of the KlipShow build series, we'll tackle some weird and almost bizarre WebSocket issues in our test environment, which will ultimately lead to us having to slightly refactor how we handle authentication over our WebSocket connections. Once we get that sorted out, we write the rest of our integration tests and make sure that from a features perspective, we're in a good position to be able to start working on the process needed to get our application deployed with DigitalOcean. In order to help a lot of that process, we're going to use the new Kamal build tool from 37 Signals. And we'll also set up some continuous integration, continuous deployment workflows using GitHub Actions. This is the first time I'm going to be using both Kamal and GitHub Actions and a DigitalOcean Droplet for a Rails app, actually. So this is going to be a really fun episode, both for me and hopefully you. Without further ado, let's hop on into episode 6. Well, we ran into some more weird issues with our system integration tests, and I'm just documenting my progress on this paranormal activity style because this is just weird stuff to run into. But we were inadvertently still using the development environment for these tests actually running. A lot of the links for the Twitch redirect URI were going to port 3000, and those were running and working because, again, those services are running in Docker. So a little confusing there. And it was a weird issue to track down, but it led us to the underlying problem, which is how we were trying to authenticate the connections coming over via WebSockets, specifically with AnyCable. So the reason this was working before with cookies was because the AnyCable host was accessible by the same host that we had our web server accessible on, localhost. We were able to get to localhost port 3000 and localhost port 8080 on the same host, so those cookies carried over. When we went into our test environment, the authentication broke, which was part of the issue that we ran into. We illustrated some of the other issues we had at the end of episode 5. But the underlying issue here is that the AnyCable host and the Rails server hosts are actually going to be different. So those cookies aren't going to be able to be accessible from the Rails server and the AnyCable because they're from different hosts. And I was under the impression that mounting the AnyCable endpoint in our routes here proxied those requests to our AnyCable instance, and it appears that that's not the case. It appears that that's just how ActionCable works. If you're using it without AnyCable, you're just using it as the Rails backend. I could be wrong on that, but ultimately the issue is that we can't rely on cookies-based authentication for these WebSocket connections, and how we're getting around that is just using the same alert token parameter for these WebSocket connections, because that's what all of this is kind of based around, is that alerts channel anyway. So if we introduce different logicked WebSockets channels in the future, we'll maybe scope this down a little bit more to be specific to the alerts token, so that we can keep things kind of permission based and they're not able to use that token to get anywhere in the application. Right now, the only WebSocket functionality that we have is around the streamer alerts channel. So if we ever add channels in the future and we don't want that alert token to be accessible with those channels, we're going to have to come up with a slightly different strategy. But for now, we changed our helper method here, the ActionCable URL, to use local. This is how it was working in development. Was we didn't have AnyCable host set in our development server, which means it was falling back to localhost, which worked because we have those ports forwarded from Docker to our local machine here. So as you can already tell, this is a really strange issue and kind of weird to track down. But it led us to all of the issues that we were having, and this is why tests are so important and that kind of thing. So we're just including the token here, either passed in the method where it's used in the views to ultimately go to those React components that are using it, or if we have it set in the parameters, like on the alerts consumer for the OBS browser source, we'll get that from the parameters there. So we confirm that that's working, and we confirm that our Q tests are now working in the test environment, isolated to the AnyCable instance, test instance, and the test server, which is what we want. We need to test it in isolation. And if anything, what this has proven was there's a flaw in our underlying authentication logic, which we would have found out in production, but it would have been hard to do. And hopefully this will make the transition to production a lot easier, because we took the approach of having an isolated test environment as well as a development environment. So definitely worth shouting out there. As of right now, these are working, and according to all the logs, it's all happening to the test environment, not to the development environment, which is how it was working before. So if anything changes, I'll be sure to update the video. While playing around with the new functionality that we have live on stream, I found that the queuing system was getting progressively slower in skipping to the next clip as we added clips to the system. This is clearly problematic as we want the clips to be back to back. So I was expecting there to be no latency, and the fact that this did get worse as we added clips definitely made me feel like there was an issue, which there certainly was. Using the Chrome developer tools here with the remote debugging with OBS and the browser source, while we trigger clips here, we'll go ahead and queue up a few there.
Fuck?
We can see it
What
here.
in the fuck is happening, man?
We can see it here in the developer tools, and we'll be able to see the console as well. And what was happening was I was seeing fetch requests to delete resources that didn't exist, meaning there was something that was holding on to a reference to each of these individual streamer clip queues and was trying to delete it, and that event listener that was happening kept getting duplicated each time that we added a clip to the queue. So what we had to do was look into the useCallback hook here, which is a way to get a stable callback. In other words, the reference to this callback will not change throughout the life cycle of this particular component. It will only change if any of the dependencies that you give it here change, and if you don't give it any dependencies while this component is mounted, the reference will be the same. Now, the reason that is important is because this component can re-render, and if we declared this as a normal callback, we would have a different reference to that function so that when it came time to unmount the component, we wouldn't have the right reference to send here to have that event listener removed so that duplicate iframe messages weren't getting processed. So the process that we had to or the pattern that we had to follow here was to use this useCallback hook, which gives us that stable function reference. It will never change the reference to this here. When the component initially mounts, we're able to add that event listener using that reference, and then how many ever times that the component may have re-rendered, if it did re-render, we'll have a stable callback to pass in to the remove event listener here so that the next time another component re-renders, it won't have stale events that need to be processed and ultimately fix that underlying issue. And I wanted to give it a call out here because it's required a relatively thoughtful debugging kind of approach here with using the Chrome debugger tools. And, you know, this error wasn't immediately obvious. We weren't getting any issues with OBS. If we did a little more deep diving in the server logs, we probably would have found duplicate delete requests, you know, associated to a 404 status code. That could have led us to another thing, but we needed to see what was causing that. And I think the approach that we went on with this debugging thing was totally appropriate. So that tying it into a new callback that I'm not super familiar with here, with this right here was a great kind of pattern that needed that. So hopefully that illustrated, you know, the issue that we ran into, how we immediately knew that there was kind of a problem. You know, these WebSocket events that drive the videos and skip the videos shouldn't take any time at all. Everything is happening on the local machine. So if at any time during your kind of development process things aren't functioning super quickly, it's usually indicative of some sort of problem. The development environment should run very quickly, particularly because we're limiting the use to only really one user. So hopefully that's a good call out there, and we'll continue. Right now we're building out some additional system tests for our integration stuff, making sure that the implementation is now working in the test environment. So far, that seems good, and if I run into anything else, I'll be sure to update this video. Okay, our integration tests are completed. We didn't run into any more bugaboos that were worth mentioning, and we're to the point now where we want to get our application hosted in its entirety on a production server. So we're going to play around with Kamal, which is the new deployment tool from 37 Signals, and it's what they use at 37 Signals to deploy all of their applications. So I figured we would give it a try. Now, normally I would reach for Heroku because it's a very straightforward process for deploying public production application and wiring a Postgres server and other instances that we may need, like Redis and stuff like that, to it. But recently I've noticed that Heroku's costs have gotten pretty steep, And I'm really looking for alternatives, particularly for my main SaaS that I run for my business. So I figured this would be the perfect opportunity to try both Kamal and DigitalOcean, which I hear is a great alternative to Heroku. If you haven't already, go ahead and sign up for a DigitalOcean account, and I will actually have an affiliate link in the description below. If you'd like to sign up for DigitalOcean using that, you can support the channel with no additional cost to you. If you feel weird about doing that, just go straight to DigitalOcean and sign up for an account. The process will be the same, and I will not get a commission. So once you get that taken care of, you'll sign up for a droplet, and that's the different instances of basic computing power, like a dyno would be for Heroku. And I chose the 25 gig disk, 1 AMD vCPU, 1 gig of memory, and I believe this comes out to $7 a month or so. So that's way cheaper than a standard 2x dyno for Heroku right away. So we're already saving money right off the bat. Now, this most likely isn't going to be the actual production environment in its entirety that we'll have when KlipShow is live. So from here on out, you'll see here we have this labeled as KlipShow staging. So I'm going to have this labeled as KlipShow staging in here and in the deploy file that we'll go over, which is what Kamal uses to actually push out all of our code and deploy the server and that kind of thing. The reason we're doing that is because this server is going to have both the Rails server, the Postgres database, and an AnyCable instance running all in the same box. This doesn't give us a whole lot of opportunity to scale horizontally, which is a nice feature to have in the situation like KlipShow, where the amount of resources that we may have if KlipShow starts to take off can be variable. So it would be really nice to be able to scale that up when needed and then scale it back when not needed. And it's going to be a lot easier to do that if we're able to scale in that kind of horizontal fashion by having separate services on separate instances. But it should be great as a next step for getting this public. I'll enable it for the stream here myself, and I'll actually start using this when we're not working on KlipShow, and it's something that's like where the origination of where KlipShow came from is kind of scratching that itch of like having this functionality even for my own stream. So this will bridge that gap. It'll get us one step closer to our finished production environment, and we'll be able to play with Kamal along the way. So new Rails applications will come with the Kamal gem already installed. If you are running on a different version of Rails, you'll have to install it separately. But once you have it bundled, you'll be able to run Kamal init from the command line, and that will generate a deploy.yaml file. And this is at the crux of what makes Kamal work and tries to be a low configuration deployment strategy for this type of situation where we have pretty much a bare metal box or a virtual private server in this case, and we're able to deploy to just a regular Linux distribution ourselves. And so it follows a lot of the Docker containerization patterns and that kind of thing, and it will have some helper methods for being able to kind of bridge these accessories, as they call them, which is what the Postgres instance and the AnyCable instance will be. There'll be accessories that are hosted on the same host, and how this will work is the services will run locally and communicate with each other locally, and there will be a proxy server sitting in front of those services that is actually exposed to the outside world. And this gives us a layer of protection so that you can't directly get to the Postgres server from the internet. Only the web service will be able to access that locally, and we don't have to worry about exposing it and having to firewall that and that kind of thing. So by default, Kamal uses the Kamal proxy server in order to accomplish that. First up, the first thing we'll do is declare our service name. In this case, it's going to be KlipShow. And we are going to host the Docker image that actually runs on our virtual private server. And in this case, I'm just using the Docker Hub registry. Docker Hub appears to allow you to have one private image hosted in a repository at a time, and I'm currently taking advantage of that. So in order to set that up, we're going to use the username / whatever the name of the image that you want it to be is. And in this case, my username for Docker Hub is oddjob, and the image name is just going to be KlipShow. You can follow the exact same convention for your app and for your username, and it should work. And Kamal also allows for the ability to deploy to multiple servers, which we might take advantage of in the future. And our production environment will most likely have a different setup with a load balancer and having separate services so that we can make sure we can achieve that horizontal scaling. So once we get to that point, we'll definitely circle back to that. But for now, we're just setting up one server and we're setting the host to the public IP v4 address that got assigned to our DigitalOcean droplet. And this is the address that Kamal is going to SSH to in order to make sure Docker is installed on the system. Pull the image that is built from your application here onto the server, and then run the other commands to actually start all these services and make sure that it's running as it should. This is something that I had to figure out here, and I'm sure there's a better convention for this, but I couldn't find in the documentation. So I had to find in AnyCable they had a demo version of deploy that had a Rails app and AnyCable in it. So I had to infer from there that you can have this options field passed in here, and you can explicitly give it a network alias that you can use elsewhere. And you'll see in just a moment how that was necessary for our AnyCable instance, because we had to tell AnyCable the address that they needed to send the RPC commands to, since we're doing HTTP over RPC. And that's how we kind of came to that conclusion. So I'll call it out here since we're doing like a top-down approach here. But what this will basically allow us to do is get to this isolated container within the Kamal network that gets created for us. And it's all running on Docker. So it's kind of a helper method on top of Docker, specifically wired to be able to have this kind of deployment. Since we're deploying all these services on the same host, we are going to use that Kamal proxy that I mentioned earlier. And in order to enable that, we just have to specify proxy SSL true. And what this will mean is the SSL certificate will terminate at the proxy server. And that means that we don't have to have HTTPS between our local instances, which should be fine, again, because those are not directly exposed to the outside internet. The request will come in through the proxy, and then the proxy will locally route those traffic to the individual services that they need to go to. So we'll specify the host here. And in this case, this needs to be the actual domain name. And the reason for that is Kamal is able to automatically register your host name with Let's Encrypt in order to get your TLS certificate in order for SSL to work. And I can confirm at this point that it does appear to work if you follow this convention. So what you'll do once you have your domain is, in my case, I'm using a subdomain. If you were using a root domain, you would omit this. But I'm using staging.klipshow.io. And that has, on that domain, through my registrar, I have a CNAME record that points to the actual underlying box. So the reason that you had to have the CNAME record is for the SSL certification. If you didn't have SSL enabled, you could just set this to the IP address. But everybody's going to need this kind of working. So that's how I did it. And again, the reason I use this subdomain here is because this is for staging. In the future, this might be just regular klipshow.io. That's why I have the .io and the .com domain for KlipShow. One for like the marketing landing page, and then one for the actual application, to try to keep them separate at the top level domain level. So hopefully that will work out. And then in the registry section here, this is going to be wherever your Docker image is going to be hosted. So DigitalOcean has a registry. I might migrate to that in the future if we need some more functionality, more hosting space and stuff like that, which is what's limited currently with Docker Hub. But since Docker Hub allows you one private repository, we're taking advantage of that. By default, it uses Docker Hub, so you don't need to specify the server, just the username that you're going to be using to sign into Docker Hub. And then for the password section here, you'll notice it kind of a different notation. And we're just specifying Kamal registry password. And how this is actually functioning is in the Kamal secrets file, which gets generated when you do the Kamal init, I believe, function. And it's in Kamal secrets here. So Kamal will run this, and you'll have access to these kind of secure keys. And what DHH does from 37 Signals, he has a video on kamal-deploy.org that I saw, and he uses 1Password for these different services that you need to have secure keys for, and you don't want to store them in plain text. I'm just following the pattern of having them stored on the machine that I'm deploying from, and then keeping them out of version control. So this won't ever end up, these keys won't ever end up in version control where they're stored in plain text. They'll just be on my machine stored locally. And this will work for now. They do have some abilities to use 1Password, and you can kind of go and have them stored in like a vault and use the 1Password API in order to retrieve them and to decrypt it. But for now, wherever you see those Kamal secrets, it comes from this file here. So this is what allows us to prevent having to store these sensitive pieces of information in plain text on the deploy.yaml. It's kind of a way to circumvent that and then allow for you to be able to like fetch in a dynamic way these keys. So in this case, I'm just running a bash command to output these text files. But if you're using 1Password, you'd be able to set that up as well. And then underneath the environment section here, there's two different sections. So secret, which will be, it will pull those values from that Kamal secrets file that we just went over. And then clear just means things that are safe to have in clear text. So in this case here, I'm setting the database URL, and the database URL follows the convention of the service name, so or the app name. So KlipShow, I guess you'd call that the service, and then the accessory. So the accessory name down here, we haven't gone over that yet, but you declare your accessories down here. We're naming that DB. So that's a very Docker-esque kind of way of doing that. So Kamal just sets it up so that you have the service, and this is so you can isolate and have different services that go to different hosts and that kind of thing, I imagine. So Kamal follows that pattern of service dash accessory, and that's how we're able to use it here in lieu of the address, since those are two isolated containers and they're going to be only communicating with themselves on the isolated host. Our Twitch redirect URI, this is just something I store in the environment variable for configuration purposes. So we're using that in the Auth controller, I believe, to make sure that the kind of Auth dance works, and we can kind of easily configure it based off of that environment variable. Making sure that the Rails environment is set to production. The AnyCable host environment variable is what we use in our application helper file, and it's in this method right here, the action cable URL. We're using that to be able to dynamically set both secure WebSocket and the actual host itself. The host environment variable I found was needed for the URL. We're using the route helpers in a lot of areas, and since we're using a subdomain of staging, we had to specify that the entire host is staging.klipshow.io, something that you might run into if you have a similar setup. I haven't touched anything really in the builder section, just making sure that the master key is there, and the master key comes from the Kamal secrets there. The reason that's important is for all of the tokenization and cryptography is based on the Rails master key. So during the build process, that's necessary. And to that end, we're also using the Kamal asset host way of going about things. Let me see if I can get that. So what the assets do for Kamal here is it stores a volume that the proxy can be able to point requests to instead of having it go directly to the application. The reason for that, as you can look at from kamalmanual.com, it goes over this in probably a better way here than I can. And basically, in between deployments, if a request is happening while assets are being compiled, it might serve the wrong version, and you can remedy that by having it from the proxy point of view, just serve those assets from whatever's current in the volume that's shared between the containers as they're being deployed. So I think that is the basic gist of it, and we've gotten that working in this kind of proxy environment. If you have any other issues, kamalmanual.com should be great for that. And I just found that from a Google search here, and it looks like they have a lot of other good stuff on Kamal as well. So we're setting that to Rails, Public, and Vite. And I had to chase my tail a decent amount on this part here, mainly because I didn't find any other examples of people using Vite. In the example that DHH has on kamaldeploy.org, he's just using regular import maps, I believe, or just whatever Rails comes with by default, and we're deviating from that slightly. So the build process was a little difficult to figure out. We got it taken care of, and hopefully we'll be able to explain it here as well. But basically, just remember that we have it stored in Rails Public Vite, and when we go over that part of kind of the setup so far, we'll reference that. And if you're not using the asset path, you have to come up with something else. So we may eventually, I think that the right thing to do would be to have a proper CDN for all of the assets. And once we get to that point, we won't need Rails to serve our assets at all. So in the actual production environment, most likely we'll be able to just comment this out. So to actually SSH into the DigitalOcean droplet in this case, or the VPS of your choice, I had to uncomment this here, and we're using the root user, and by default, DigitalOcean uses the SSH key that you'll set up, that you'll add with them, just like GitHub. And I had to specify a special key because I use a few different identities for work and one for this kind of stuff. So I had to specify my key here. You may run into that as well if you're doing the first run of Kamal deploy and you get an SSH key error. You may have to explicitly declare where it is. If you have the default path, you'll most likely be fine, but in case not, it's really simple to specify that here for Kamal to pick that up. And then probably the best part here, I think, of the Kamal kind of approach is the accessories path here. So we're able to set up these services very similar to our Docker Compose. You'll notice it follows a very similar convention. And so we're basically starting with a name. So this is the name of the accessory. In this case, this is our Postgres instance, and we're using the latest Alpine version of Postgres 17. And then for the host for that, you'll just put the IP address again. We're having all of this hosted on the same machine. But once we change these up and we have these services running on different VPSs or whatever, we'll be able to declare them separately here. And that's where Kamal should really come alive. And then I followed what DHH did in his video. He's using a MySQL database, but the concept is going to be the same. And in order to prevent this container from being exposed to the outside world, you specify in this way here that we're going to bind to localhost. And then from that container, we're only binding to localhost, not all of the network adapters. And that could lead to that being exposed to the outside internet. And we don't want anything yet getting directly connected to the database, right? So since this is all on the same machine, we can keep it local. And this is how we're able to declare that. Since we have Postgres on the same machine that our web service is on, we can really cheat and get easy Postgres credentials here because again, it's isolated from the outside internet. Nothing can get through. And so we're able to take advantage of just kind of dummy passwords here that would otherwise be easily guessed and would not be very secure. This is a really interesting part here. So the files section here, Kamal will follow a convention that gives you kind of an entry point for these accessories. And the reason that they set that up is to kind of seed the service so that it's ready once the web app and the build process needs it. So what I had Cursor make here was the SQL needed for all of our databases so far. And when I got to this point, I was running into some issues with SolidQ. So at this point, although we do plan on using SolidQ for managing our background jobs and that kind of thing, I do have it disabled for production just to make sure that we could get past that build process. Now that I'm more familiar with Kamal, next time that we need to kind of expand that and we need to enable it again, we should have a much better chance of having that go through without a hiccup. But the reason that's relevant here is the tables and the database itself will get created here, and that way when Rails goes to connect to the database, it will have the right table to do that with and the right privileges and all of that stuff. So this kind of thing goes here, and then you specify the location of it and where it's going to following this exact kind of convention here. So they may have more documentation on that, and it's kind of like the black box part of Kamal that could be a double-edged sword. But so far, this does seem to work. And if I run into any issues with it, particularly when we go to enable SolidQ again, I'll be sure to mention it for sure. And then the directories here, I think this is just very similar to setting up the volumes that we would in Docker Compose, just making sure that the DB service has disk space in the container and has a volume and all that kind of thing, because I think that's how that's directed there. So that's all for the DB service. And then for the AnyCable service, it follows the same convention. AnyCable has a supported Docker image. This is going on the same host as the other accessory. And on this one here, we do have a proxy option. And the reason for that is we need the Kamal proxy to send requests specifically to this service when it comes in on this host. And again, that's kind of the downside to having the all of the services hosted on the same machine is you have to go about it that way with the proxy doing the heavy lifting there. But for staging and for demonstration purposes, this works really well. So in order to do that, it follows the same convention as it did up here for our web service. We'll need to declare that this will have a SSL endpoint. So proxy itself will terminate the SSL certificate. And again, the great benefit of Kamal here is it's handling the registration of let's encrypt so that we get our TLS certificate and we just have a secured endpoint that's already set up with the keys and everything already configured. So it's really nice if you follow that convention. And then I also just, again, have a CNAME record on my klipshow.io domain for ws.staging. So that follows the same convention. You don't have to have a subdomain, but this is what I'm using at least for staging. The app port that it's going to go to, as you can see down here, we're having AnyCable set up to run on 8080. So we just have that proxied connection on port 80 or 443 in this case, go to from the proxy to our AnyCable instance on 8080. And Kamal also has a health check mechanism set up. And since AnyCable has an endpoint for that, we're able to tap into that and make sure that as soon as the service comes online, the rest of the build process can continue. And then we're able to set up some environment variables. Everything is in clear text here except for the AnyCable secret. And you'll notice that that is one of the entries in the Kamal secrets here. And I'm just following that same convention, having AnyCable.key text file that I use Rails secret to generate a secure secret for. And once we expand and need to have the keys easily distributable, we'll come up with a different solution, but for now that should work fine. And that's all I did to generate the AnyCable key there to make sure that it is a secure key. It's not in version control. I think that checks the major boxes that we need to make sure for that. And we also have the added benefit of it being, again, on the same machine. So there's not as much of a gap there because, there's not a separate external service, I guess. So that may change in the future, but for now, we have a ragtag setup that I think will actually take us pretty far. So the only thing, I just took this basically from the Docker Compose file. I did have to enable access logs here and set the log level to debug because I was chasing my tail on this issue here. So as I mentioned above, the network aliases that you can specifically set for these services, I didn't know the convention that Kamal follows. In the documentation, it's not super clear if it's used as app or KlipShow web. And it's different because if I had to SSH into the container or into the VPS rather, and I had to look at the Docker instances that were running, and the KlipShow web gets a unique string attached to the end of it. And I'm guessing that has something to do with the proxy and how it's able to do the zero downtime deployment stuff. So in order to dynamically be able to function like we needed to, I didn't know what the default convention was. So that's why I manually declared it as KlipShow web. Now internally, this AnyCable instance can properly get access to our isolated web server to send those RPC commands over. So hopefully if anybody is doing a similar setup, and particularly they're using HTTP RPC, this is what you might have to run into. Or if you saw somewhere in the documentation where the default alias convention is, it would make sense that it's KlipShow-web. For some reason, that just wasn't working for me. So hopefully that helps out. It was a gotcha that did take me a little bit to figure out. But now we're able to get this going. And the first deploy that Kamal will do, you'll need to do Kamal setup. It will make sure that the host has Docker installed. If it doesn't, it'll go out, fetch the current version of Docker, and install it for you. After that, you'll just run Kamal deploy, and then it'll run through over SSH, set up everything, pull the Docker image down on your host file, on your host VPS rather. And once that's set up, you should be good to go. So I can demonstrate here in our staging environment. We're at staging.klipshow.io. You can tell that we have a proper SSL certificate. We're not getting any issues. We're verified by Let's Encrypt. All of that was done automatically by Kamal. And to show you what the deployment process looks like, I'll go ahead and run this here. Another gotcha that I ran into was any file that is not committed in the current instance of your application, Kamal will ignore on the deployment. So if a change that you're trying to make in order to fix a failing Kamal deployment or something like that, you need to make sure that those are committed, because that's something that I ran into as well. And if there's a way around that or a flag, which I'm sure there is, feel free to share it below if you get to this point and you know it. If I ever run into it, I'll be sure to share it as well. But that was another gotcha that I thought deserved a call out. So I'll do Kamal deploy here, and I'm going to tack on tack V, and V will give us a little bit more verbosity in the output here on the logs. And it's particularly useful at first because a lot of this can seem like just kind of a black box or magic or whatever, and you need to really be able to understand what's going on, especially if you need to debug it, which I've read online that a lot of people have had to do, myself included. So what it will do is it will take the current Docker file in your app, build the image, and a part of that image is compiling the assets here. That's one thing that I forgot to mention on that was another bugaboo that I had. So our Docker file here has what will actually run for our web service at the end, and all of this is kind of preparation for that. So I had to set up my environment variables here, mainly for Vite. So for our OAuth sign-in logic, I have this kind of scoped out to an environment variable because locally we want this to be localhost, and in production and in staging this will be different. So we have this set up for an environment variable here. And the biggest thing that I ran into was getting the assets to compile. So we're actually having the assets compile in the Docker file here. I thought that the standard convention would be to use a Kamal hook, which is what Kamal can run after a deployment or before a deployment or before a build. There's quite a few hooks that they have, but it seemed like that didn't work because running the remote command for Kamal, particularly for building the assets, sets it up on a container that's thrown away. So if you do that, if you use the Kamal remote, like the Kamal console or whatever it is, assets precompile, you'll see all of your assets precompile in the terminal output, but it's not anywhere to be found. And the reason for that, if you look at the Docker command that actually gets run, the command is run inside of a container that's just the volume's thrown away. So that's why having your assets actually compiled and built into the Docker image is, I think, the better way to go about that. And the biggest thing that I ran into, weirdly enough, was the Rails secret key wasn't getting recognized. I was trying to set it explicitly in the environment. It wasn't working. I'm not exactly sure why, but it took me having to look into the actual Rails code itself of where this exception was getting raised to find that you can pass in secret key-based dummy equals 1. Because in this case here, just to compile our assets, it does boot the Rails app, but we don't need a secure token for our assets to get compiled. That doesn't contain any sensitive information, and the fingerprint that it needs in order to break the cache is generated separately as well. So it's kind of a weird hack that you have to do here, but if in the context of running this, if you specify secret key-based dummy equals 1, bundle exec Rails assets precompile, it will locally create a new key, and this doesn't cause the precompile to fail. So this was a really big issue that I ran into for a weird reason, and it just didn't seem to be documented very well in the examples that I saw. And I think maybe it's because I'm using Vite instead, and the Vite build process, Vite Ruby, like I said, boots the Rails app, and in part of that looks for the Rails master key because that is used in important places in the application. But this is the workaround for that. So part of the build process is running and building the Docker image as it currently stands in your application, and you'll be able to see that it's putting it in that public Vite assets file here. And how we got it to do that was in our vite.json file here, we had to add a production section here because we're running this in the production environment, and that's where it infers this from. We also have one for development and test. You can see that for test, we're using the hot module reloading server that needs a host name and all that kind of stuff. Production doesn't need any of that. So we set auto build to false, and that it will prevent the assets from being built on request, I believe. Build cache to true, so we'll cache if the build doesn't change, then we don't need to run the entire build, I believe is what that will do. And then this is where the Vite will come into play, that Vite in the file namespace. Public output directory is Vite, so that's in public Vite is where that will end up. And that is because of our specification here. We're not generating a source map, and we're minifying with ES-build to make that as quick as possible. So in order to get the assets to compile for production, we had to use that little hack for the Rails master key, and then we had to add this configuration here to make sure that everything is getting set up correctly and specifically is getting routed to the right directory, because that is where Kamal will look for the assets to mount in that volume that the proxy will use to send requests to all the assets for. Once the Docker image is built, Docker will upload that to the Docker Hub registry. In that case, in our case anyway, because that's the Docker Hub, that's the Docker registration that we're using. If you're using something like DigitalOcean, or I think GitHub has a service for that as well, it would be that. And the reason for that is so we have somewhere to, from our VPS, have all of our code and our application ready to go in the Docker image be downloaded. So it acts as an intermediary for us to be able to deploy our application that's built based off of our Docker file. And then if everything goes correctly here, you'll see some output. We're seeing AnyCable get set up, and we'll see that everything appears to be running. If you need to see the logs, this is another nice thing with Kamal here. It'll be Kamal logs, and you can tack on the F there in order to tail the logs, and that will show you just the logs for the web service. In order to see the logs of your accessories, for example, in AnyCable, you'll see I had a bunch of errors here, and this is what I was debugging that led me to that hostname issue, and I was able to have at least a clue of what was going on by being able to see the logs here of the accessory. If you just do Kamal logs, it'll just do your web service, and that will not be particularly useful if you're trying to debug something like this with your web app trying to communicate with one of the accessories. So in order to see those logs, you can just do Kamal accessory logs and then the name of the actual service here, which comes from our deploy right here. So AnyCable Go is our service in this case. If we wanted to see the logs for the database, we would just do Kamal DB, and we'll be able to see that. And if we needed a tail, we can just tack on a tac F there, and we can see what actually runs. We're connecting to SSH, and then it is outputting the contents of the Docker container, and we can have all of the logging that we need here. And that's basically it. I can show you what it looks like to SSH in here. And basically, I'm just looking at HTOP here to see where the server is actually sitting with resources, and it's using 466 megs, so about half of the memory that we're allocated here. Now granted, this is with no load, but this is with all of the services running, so hopefully we'll get a lot of use out of this. And we can also confirm here that the KlipShow dashboard is all working and staging, and we've got the database wired up, and we also have our KlipShow integration going. So in true fashion, we'll have one of ours go. If you're wondering about the green screen here, this is kind of another vision that I had for KlipShow. So having these clips hosted on TikTok, for example, in this case, but with a green background, so that in OBS, we can do a chroma filter, and that's what gives us that kind of transparent background effect that you'll see in just a moment. But if I go ahead and queue up Toby Maguire here, we can see that he is actually on the screen, and it doesn't show the green screen. That's actually OBS that's handling that. So very cool stuff there. I think that Kamal is going to serve us well. I'm very excited about it, and it was a little tricky to get set up, I'm not going to lie, but hopefully now that it's set up, it's kind of a it'll just work type of situation. And I think what I'm going to try to work into next is what the kind of continuous integration platform and pattern and all that kind of stuff follows with Kamal. So as soon as I make some developments on that, I'll be sure to add to that. But this is a major accomplishment here of having our application in a production environment. Although we have it in a staging subdomain, it's still on a server that we can have just sitting as an OBS source now, and it will just work because every time we open OBS, we don't have to worry about refreshing that source because it'll already be hosted, and we should just have seamless access, and that's exactly what we need for any of our clients, other streamers in this case, if KlipShow is going to become like a real deal. So very exciting stuff, and we'll work on getting the continuous integration, continuous deployment set up so that we can deploy often and without any headaches or without having to be on pins and needles. So I will see you in a moment once we have some more developments on that front. Shortly after getting the staging environment set up live on stream, one of our devout viewers found a bug immediately, and we're looking at it here. In the clip library, we shouldn't have the ability for a clip to be added twice. So we need to have a validation check to make sure that if a clip that is shareable already exists in the KlipShow database that will direct them to a link that the clip can be accessible from instead of allowing them to add multiple clips. So I think this will tie in nicely to kind of that fair compromise between the shareable flag and not being shareable and all of that kind of thing. So in order to get that taken care of, we had to start with our ActiveRecord validation at the model level. And in our clip model here, we're basically adding a custom validation by saying validate singular form there and passing in the method name in the form of a symbol. And then I always have this in a private block on the model itself. And basically what we're doing is checking to see if a clip with that platform and platform ID that is shareable exists. If it does and it's not the clip that is currently being used in this case here, add an error to it, prevent it from being saved. And we're doing something a little unorthodox here. We're using the Rails application, the routes helper, normally what we would use in an action view. We're using this here in the model, and we can access that there explicitly by going Rails application routes, URL helpers, and then we have access to all of the Rails generated route method names here that we can pass in. And how I'm doing this here is we're using the Klips library URL path, and we, in our routes file here, since we're not using one of the default methods like resources here that sets up the names for the URLs as you would expect, we're passing in that as flag here in order to be able to access this URL in this way. So that's how that is bridged. And then we're passing in with the URL method here, we can pass in parameters. I'm passing in the ID of this existing clip, and my thought process behind that was if anybody ever finds themselves in a situation where they're trying to add a TikTok that is already in the KlipShow database and is shareable, go ahead and have them use that instead, and this will prevent duplicate videos from getting added. So I think that's a necessary thing to go through, and it gives us an opportunity to look at how we can kind of factor that into the development of the application now and that kind of thing. As a part of the kind of testing this whole thing here, we are going to test that in a integration test that URL actually gets displayed as a clickable link that we can have them presented with if they find themselves in this situation here. So here I'm going to add this Theo Von clip again. So I'll do that by going to add clip, and I'll paste in the URL for the original clip that exists, and I'll fill this out here. And if we save this, we'll see we get a toast message here that shows that the clip wasn't saved. And then we also have this in a interactable way where the end user can just click on this to get to the existing clip and be able to add it to their clips there. So we are testing to make sure that from a ActiveRecord validation error, we can get the URL of the underlying clip and then have it in our React component here actually clickable as a link. So in the component for the clip form here in React, we are using our KS fetch wrapper, which sets up the call needed to have an AJAX request sent to the Rails server. When a clip actually gets set to save, this function ultimately runs, and the result of this will have errors potentially in the response body. So we check for that, and instead of using the turbo method here to visit the clips index path, which would normally show the toast message in the top right hand corner and go back to the index path for all of your streamer clips, instead of that, we just set the form errors, and down here in where it's actually rendered, I am doing a test here to see if in the map for each error, that's how it kind of gets shown as a bulleted list, we map through them and add them to an unordered list here. And what I do is I basically check to see if the error that we're dealing with in particular matches this pattern that we have. If it does, that means that it will also match the pattern of a URL, and we can expect that by just taking the end portion of the error itself and having that put into an anchor tag so that we can have our error message kind of redisplayed here. So not really super fancy, but what it does achieve is the ability for us to have this here so that in the event that they're trying to add a clip that's already in the database, they have an easy way to get to that and have it added to their library. We finally got our GitHub Action workflows figured out for our CI and deploy workflows, and I'll take some time to go over that now. So the CI workflow started with, I believe, a new Rails application. There were a couple things in here. So the scan Ruby job was here, and the lint job was here. And so this is using a gem called Brakeman, which is supposed to help with common Rails security vulnerabilities. And I'd never used it before, so it figured since it's already kind of enabled, I'll leave it here and see if it helps. The next step here is the linter, which is using Rubocop, and that's fine with me. I'm completely fine by adhering to that. I think the Ruby LSP, when it is working, I think it uses that by default for its formatter, so it's good to follow that. And then our test suite here gets a little bit more complicated. So we're running it on the Ubuntu latest tag here, and then we have to set up our environment. And what we're able to do here is use localhost for the network mapping to actually be able to run the tests. And so we're able to use localhost here for the database URL for the test environment. The reason for that is we are exposing in the services category here, which runs underneath the test job, that the Postgres service runs as very similar convention to Docker here, just straight up. I think this might be something different, though, that GitHub Actions intercepts. I'm not sure. But yeah, so we're able to bind to localhost there because we can forward the ports in the test runner. It shouldn't be an issue to do that. In the secrets, we're going to have a Rails master key set up, and how the secrets work in GitHub Actions is in the repository settings, you're able to go in there and set one time the key and value for each of these secrets. So to get to that, you'll go to settings and then secrets and variables, actions, and then you'll see all of what we have set up here. So the secrets here are, you can't access them once you've set them once. It won't show, and that's to keep them secret. And so anything that we need to not have in plain text and anything that needs to be filtered in the output for the GitHub Actions can go here. And what that allows us to do using this in our workflows, which by the way goes in the github.github directory, workflows directory, and then ci.yaml was already here. So if it's off of a new Rails app, by default, it looks like it will include this CI for you. Not including the test, though. I added all of this. So we're able to use the notation here and reference those secrets with secrets dot, and then it's just the capitalized name, same key that is in the repository settings. And then any other environment variables that can be put in plain text should work here. So we're just having to set the AnyCable host and port to run for our integration tests. We're having those run as well as our regular specs. So another nice thing here is for this test job, we're able to declare services and set them up like a Docker image. So we do that for the database and for AnyCable. And with AnyCable, I ran into an interesting situation where there's not a naming convention like Docker has, I guess, as far as like being able to reference the network by job name or by service name. I couldn't get that figured out. Normally what you'd be able to do here is set this to whatever the instance is that the test service is running on. Since we don't have the test server running in its own service here, it's just running in the job of test. The test job is treated as the host, and the AnyCable service here is actually running in a containerized Docker image. So anyway, in order to get communication from the container to the host, we can't bind to a service name because it's not running in a service. So I had to add a option here and have the host.docker.internal mapped to the host gateway hostname. And what that allows us to do is set the host of the test environment, in this case, the test job here, and on localhost essentially, and port 3000. This is how we're able to get to the RPC endpoint in Rails in our test environment. So that was definitely a gotcha that's worth calling out there. The AnyCable secret environment variable, same thing as what we had in our Docker Compose local test secrets. That is the same. And then we have our steps section here. So it uses these prefabbed actions, and they have their differing versions. Currently, the version for checking out the code into the test runner here is action/checkout v4. And then there is an action for setting up Ruby. It's great. It looks like it takes 2 different flags here. Same Ruby version as our current Ruby version, and we're going to use a bundler cache so that we can get faster builds for this step here. After that's set up, we should be ready to prepare the database. So run the Rails DB prepare command, and then we're using the same secret key-based dummy environment variable hack that we had to do. It's not really a hack, I guess. It's just not something that was immediately obvious to me. And I'm starting to see it more, actually, as we go into these kind of GitHub action examples and stuff. So maybe it was common knowledge and I just didn't know. But doing the same thing here in order to precompile the assets, and this will run Vite and have all of our Vite packs set up for the integration tests. And then I had to figure out how to debug the GitHub Actions in order to figure out exactly what was causing this issue with AnyCable. Some of the specs were not passing, and it wasn't immediately obvious as to why that was. And I figured it would be good to figure this out anyway for future kind of dependencies or future evolution of the application to be able to get into our environment if we need to from an SSH environment. So we're just having this run conditionally. And if we look at the very top here, there is this on section. And this is very important because we're able to manually run this workflow from GitHub if we declare this workflow dispatch property. And it's really cool. This supports the ability to declare some inputs in kind of a dynamic way. So we can have it use this default debug input, and basically on one of these manual runs, if this debug flag is set down here in where we're actually checking for that, we'll check to see if the event name is from a workflow dispatch, and then we have access to this inputs.debug, and this debug is coming from the input that we just declared at the top of the file. So this will conditionally run, and it runs something called action teammate, and it runs kind of like a reverse shell. It basically hosts something from the container that you're then able to SSH in through this service. So it was just something that I looked up, and this was the most common thing that I found. So it's what I went with, and it does seem to work. So we're declaring this with the limit access to actor flag, and this prevents us from having to use GitHub access tokens. So it will use, from my understanding, whoever instantiates the workflow or runs the workflow from GitHub, it will use their authentication credentials in order to have the code run with the proper permissions and everything, if I understand correctly. So if this is not run, it will get skipped, and we will run to our RSpec. So this will run our entire test suite, including the integration tests. And then something that was nice that I had to do as well in order to be able to debug something was have an action for the upload artifact copy bar screenshot. So this just basically uploads. This is a standard, it looks like it's a standard GitHub action, and it will allow you to specify the name of the artifacts that you're uploading and then a path from the test runner of where you're trying to look for that. And it's really nice. So this works perfectly. We're looking for anything that is a screenshot, which will follow this directory path here. And if it has a built-in flag so that if no files are found, it will just ignore this altogether, and then it will retain them for 7 days. So in order to get these artifacts, you just go into the workflow, you go into actions rather, and then you will go to whatever action that ran that you need to get the artifacts for, and then at the very bottom in this area here, there will be a section to download a zip of your artifacts. So in the case of needing our integration test screenshots, it works very well. So this covers the CI portion of our testing environment, and we have this set up on every pull request to run. If we push to master directly, this will also run. We're going to discourage pushing directly to master, and instead have pull requests be what is the only mechanism to have the code enter into on master. And we'll be able to set this up with branch protection if and when we're able to upgrade to GitHub Enterprise, because this is a private repository and they limit that functionality on the free accounts, or in my case, the pro accounts, to only public repositories. So for now, we'll just have to follow the pattern of only having the code enter master through a pull request, and if we ever expand our team, we'll address that. Other than that, we're able to manually instantiate it, and I think this will handle what we need. And so the thought process behind this would be having the CI workflow run. This uses Brakeman and the Rubocop kind of linter, and it runs our test suite as well. If any of those steps fail, the pull request won't be able to merge right away. We'll know that, and then once the pull request is merged, we'll be able to run the deploy workflow, which actually uses Kamal to get all of that packaged up and sent over to our DigitalOcean Droplet. Would it be worth making a service host? Sorry, Critical, I don't know how long ago you just said that. What do you mean? Set up a host locally instead of running in the test mode. We have I have this like set up in like a staging environment, mainly just to make sure that we have the ability to get our service, like, so we're using this thing called AnyCable, which is its own service. We're using Postgres. Those are the two dependencies that we have aside from Ruby. And so I just wanted to make sure, and we're using this deploy tool called Kamal, which ships with new Rails applications and is kind of like the de facto deployment tool. And it allows us to host it pretty cheap. Another machine or a VM box. Yeah, so I just have it on a DigitalOcean Droplet. I just have it on a $7 a month DigitalOcean Droplet for staging. So in our GitHub workflows deploy.yaml file here, this is a brand new file that we created, and we're calling the workflow deploy. We're setting this up to work on pull requests only to master, only when the pull request is closed. And this is what I'm thinking that we'll be able to do, is have the CI workflow run on all pull requests, and then only will the closed pull requests will the deploy run. And in order for a pull request to get closed, the CI workflow will have to pass first. So I'm hoping that that will continue to work out, as it looks like it is so far. Again, we're adding the workflow dispatch comment here. We do not need to input anything else. This will allow us to run this without any of the inputs. We don't need any inputs here, but we may need to manually have this workflow run, and that's what this command does here. And that's what this property does here. So this only has one job here. It's called deploy. And we're basically doing, in the GitHub action context that this runs in, we have the ability to use the double curly brackets notation here to get access to the state of the pull request. And we're doing that to see if this will run only if the pull request is merged true. Again, I think that's kind of in tandem with this, that we're going to be running that, as well as allowing it to run if it is a workflow dispatch. So this will be if we have manually had this run, it will allow the job to continue. It runs on Ubuntu latest as well. And then for the environment here, we're setting up everything that you would expect that we would need. And we ran into some issues with getting the proper Kamal secrets in the environment here, because it's kind of tricky. We have GitHub Actions, and then inside GitHub Actions, we have Kamal. So there's like two layers of abstraction that are there from our host machine. So being able to pass in these secrets to Kamal while having them available in the environment that they run in, without having them stored anywhere in plain text, was a little tricky. So we set up all of our environment variables here. We're using the Kamal registry username, the same one for our Docker Hub. So again, the environment variables are the same that we use locally. And for concurrency, I was reading about this. We're going to give it a deploy production group, and we're going to prevent these from being canceled in progress. And this can make the process be either leave behind artifacts or leave the server in a state that is going to cause problems. So having this set to false seems to be the best practice to circumvent that. And then again, this should look pretty similar. We're going to pull the code again, set up Ruby, and there's an additional step here for setting up the SSH private key that we'll be needing. Because again, we need to have GitHub Actions from its host machine connect to our DigitalOcean Droplet over SSH in order to run the Kamal deploy command. So in order for that connection to work, we are going to systematically have it look for the private key, and I'm calling mine this here with oddjob appended to the end of it, so it's specific to my GitHub account. And we're basically creating a private key on this test runner here based on what is in the environment variable SSH private key. And that SSH private key is coming from, in this step here, we're able to set the environment. So SSH private key gets that from our secrets section. Same thing with the server address. And we're adding the server address to the list of known hosts, and this will prevent the need to confirm the fingerprint for this host, I think, each time it runs. If we add that server address in there to that, it will prevent that prompt. So that sets up the keys that Kamal will need in order to have the code actually run on our DigitalOcean Droplet. So the next situation that we ran into was directly with the environment variables and how do we keep them. In our deploy.yaml for Kamal, and this is where it gets a little confusing, is now we have a deploy YAML for GitHub Actions. We also have a deploy YAML for Kamal as well. So this section here sets up the credentials file to have those set up in the key. And the reason I did it this way is if we look in the Kamal secrets, how we have this set up here is to have these read from the credentials folder here, as you can see, and they're grayed out because they're set up to be ignored for both version control and in the Docker image. But what we can do, since we are able to get the environment set up that Kamal will run in, including the secrets file here, the secrets bash file here. So what we do is we follow the same process. We put in the environment variable up here, the secrets, right? And then access them to inline have a .key file written for this deployment here. And that way, we're able to keep those keys privatized. They don't have to be in version control, which would be a very bad thing to do. And I think this should work. So this was the last piece of the puzzle for me, was being able to have this work kind of based on an environment variable so that we can have the GitHub Actions work, or if we wanted to maintain the ability to deploy it from our local environment here. So this solution accommodates both, because if we are deploying locally, the files for these keys already exist, and they'll just stay on my local machine here. And then if they aren't, we will have them run in a situation where from the environment variable, they'll get set, and by the time Kamal is going to reference these secrets in the deploy.yaml for Kamal, it should just work. So the last step here is to actually run that bin Kamal deploy, and we have confirmed that this works. As you saw earlier in our deploy workflows here, we've got a few successful ones, and the only thing that I ran into, the biggest thing that I ran into, were those environment variables, being able to bridge that gap from a GitHub Actions secret to the Kamal secrets and setting them in the environment. So I think that we have that set up. It's kind of confusing because there's two different YAML files now for the deployment, but what we're able to get with this is a very cheap CI/CD kind of solution, and we'll continue to modify this. The next thing that I want to work on is being able to have this GitHub Actions workflow set up a review app for one-off pull requests so that we can test the app in isolation. It's going to be a little bit involved to do that, and since I'm the only one that's working on this right now, it shouldn't be too bad to set it up in our staging environment, which is what we're using now, and then once we move into production, we'll keep staging as kind of whatever it is that we're working on. But eventually, I would like to have that review app set up so that we can have another machine for our staging environments and be able to test all of them in isolation. Very similar to the Heroku review apps. It's a really nice feature, but we're trying to get away from the price of Heroku, and I think we can accomplish a very similar thing with a combination of Kamal and with GitHub Actions here. So hopefully that gives you a good idea here. That's going to go ahead and wrap up episode 6. The next things that we're going to focus on are mainly building out a client side interface for this so that we can have our viewers use that to trigger clips while we're going through the approval process for our extension. And we should be able to get some additional use out of the public facing like app even after the Twitch extension is approved, because I don't think Twitch extensions allow the mobile to work in mobile. So in order for us to have a solution for our mobile viewers and streamers, I think having a fallback to where they can purchase KlipShow credits with PayPal, and KlipShow will take a small cut of that instead of the cut that they would otherwise get with the bits, the Twitch currency inside of their extension. I think that should be a good happy medium. So since we have a good proof of concept now in production and used, I use it every time that I stream now, I think that we can start having the client side tested, and I think even have this start getting in front of streamers. Maybe we can reach out to communities on Reddit and see if there's any appetite there, but we'll cross that bridge when we come to it. Hey, Daisy. How you doing, huh? And that is going to be a complete wrap on episode 6. We've successfully deployed our app to a production environment. We're going to be using it as a staging environment once we get our actual production environment set up when we migrate to that point, but we still have a working version of our application hosted on a cloud service and able to be used in between streaming sessions. So this is really awesome in that we're able to emulate hopefully what our ideal customer profile will be wanting to get out of the application as well. Setting up our continuous integration, continuous deployment, or CI/CD workflows in GitHub was a bit challenging, but was really great to integrate that. I'm sure we'll be making some tweaks to it along the way, especially as our production environment changes, but knowing how that works now and seeing the potential with it, especially with hosting our own services as opposed to going the route that I've gone most of my career, which is just using Heroku and the Heroku build packs. All of this was a lot more involved, but I'm hoping that we'll get more familiar with this when we go to launch future services or expand our accessories, and we know that we're going to have the savings to count on for Heroku and DigitalOcean. The differences there are pretty decent depending on what it is that you plan on getting to and running. As a reminder, we do stream on Twitch every day at twitch.tv/oddjob. We mostly do coding projects, but we do some gaming as well, and it's a great opportunity for anybody to come in, hang out, ask any questions while we're live, and go ahead and give that a follow right now so that you can catch the next time that we go live. We also have a free Discord that you can join, and we'd love to have you in there. Same thing goes there. We have a lot of gamers, a lot of coders, and we'd love to see you in there asking any questions, sharing projects that you're working on, and just getting to know and be a part of our community. Thank you for watching this episode, and I'm looking very forward to seeing you in episode 7, where we're going to start tackling some of the client-facing side functionality of KlipShow and getting it to the point where our viewers can start triggering these clips and sequences on their own. So it's going to be very exciting. Make sure to like this video, subscribe, make sure that that bell is on for all notifications so that you get all of our good videos coming out, and go ahead and leave a nice comment down below, only if it's how we really feel about this video. And by we, I mean you. I'm not sure why I said we. I'm very nervous right now and just trying to get this outro done. So either way, I appreciate you guys. We'll see you in episode 7. Take care.